Hello everyone, I am Muhammad Mujahidul Islam and two of my friends MD Rakib and MD Alamgir. Today we are presenting chapter 4 Web Services from Web Scalability for Startup Engineers written by Arthur Estmot. Introduction to Web Services. Let's begin by understanding what this chapter is about. The web services layer is often where most of a system's business logic eventually lives. Web services promote reuse, abstraction, and integration, but they also introduce higher upfront complexity and development overhead. To make smart decisions, we must examine different design approaches, their benefits, and their scalability implications. Originally, web applications were simple and monolithic. Everything happened through HTML, JavaScript, and HTTP requests. But in the mid 2000s, companies began exposing APIs to let other systems interact with their app. This rise in integration needs made APIs a first-class citizen of web development. By the late 2000s, nearly every company wanted a mobile app, which in reality was just another user interface over the same core data. So developers began creating APIs that allowed websites, mobile app, and partner systems to all share one set of business logic. Now let's explore the main design strategies. Web services as an alternative presentation layer. The first and oldest approach is to treat web services as an add-on to an existing monolithic application. In figure 4.1, we can see a single monolithic application that serves web clients through traditional HTML and AJAX controllers, mobile apps via specialized service controllers, and partner systems through an integration controller. All of these share the same code base, same business logic, and same data access layer. Even though multiple servers can run in parallel, each one runs a full copy of monolith. There is no real separation between presentation and service layers. API first approach. At the other end of the spectrum lies the API first philosophy. Here, developers design the API contract first, the interface specifying how clients will communicate, and only then build the implementation and clients around it. The goal is to make the API the core product so that all clients, desktop web, mobile app, and partners consume the same consistent interface. Let's visualize how this helps. Application with multiple clients and code duplication. Figure 4.2 shows what happens without an API fast design. Each client, your web app, mobile app, and partner integrations implements its own version of business logic. They all duplicate similar functions but with slightly different interfaces to suit their needs. This duplication creates several problems: increased maintenance efforts, multiple sources of truth for the same logic, and difficulty in applying updates or bug fixes consistently. API fast application with multiple clients. Now figure 4.3 illustrates the API fast alternative. Here there is a distinct web service MVC application containing all business logic and data access. On top of that, different clients, web browsers, and mobile apps and partners consume the same shared API. While API fast is elegant and scalable, it's not always ideal for an early stage startup that needs to iterate quickly. Pragmatic approach. A pragmatic middle ground, a blend of previous two strategies. The idea is think about services and APIs from day one, but implement them only when they are truly needed. If particular feature is likely to be reused by multiple clients or external systems, design it as a separate web service. Otherwise, keep things simple and move fast.
First of all, take my salam, assalamu alaikum. I want to say about types of web services. Web services can be designed in two main architectural style. Number one, function centric services. Number two, resource centric services. Then the design style determine how client interact with the backend, how data is organized, and how scalable the system can become. Choosing the right type helps improve simplicity, maintainability, and performance. Then we can see function centric services. Number one, focus on actions or operations that the service performance. Then endpoint are named using verb that describe a task. Example, create users and send email. Then we can see advantage and disadvantage. Then we can see functionality, uh, OS SOAP interaction flow. That is, we can see. Then we can say resource centric services focus on resource or entities rather than action. Endpoint represent nouns that model a real example object. For example, users 123 orders 45. User standard HTTP model number 1 get, post, put, delete, etc. Then we can see advantage and disadvantage.
How to escalate web services? Following key principles are statelessness. Server doesn't store client session data, caching, and functional partitioning. Statelessness. Keeping service machines stateless, do not store session data on individual servers, make scaling and load balancing easier. Store state in database or distributed cache, for example, Redis memcache. Service machine stateless. Each request from a client contains all the information needed to process it. Servers do not rely on fewer requests to complete current requested, enables easy horizontal scaling and fault tolerance. Here is the example of keeping machine stateless. A client requested to web service machine and no state held between HTTP requests other than auto expiring caches, and stored data in separately for faces user authentication, faces shared file, faces application data, and faces case object and enquest job. Here the example of keeping service mechanics stateless. Figure 4.8 shows compensating transition to current partial execution. Caching service responses. Reduce servers load by caching responses, improve performance and scalability. Use HTTP headers, for example, ETAG, cache control, and last modified. Here the example of caching service response. Uh, Web services client server is connected to reverse proxy server, and web services are connected to a reverse proxy server. Here the another example of caching service response. Web service A and web service B connected to a reverse proxy server for server B and reverse proxy server for service A. And here use the root balancer. Functional partitioning. Divide service based on function. For example, user service, payment service, improves maintainability and scalability, enables independent deployment and scaling. Here is the example of functional partitioning. Uh, Here web service client like front-end server are connected to product catalog service and user profile service separately. First of all, benefits of using load balancer. Hidden server maintenance, seamlessly increased capacity, efficient failure management, and automated scaling, effective resource management. Last of all, thank you all.